Kia ora, everyone. And it's so nice to get up in the morning and have a shower and be ready to go. This is one of my passions, actually, the KenKen puzzles. And I've done it with many students over the years. Um, I think for the past 10, 12 years. And I see a lot of benefits from it. And I thought that's what I thought I will share. And so this is going to be more of a practical session, and so we'll be doing some examples as well. So I'll share my screen with you first. Right. Hang on. Right.
Sorry, Marla, can I just ask a quick question?
Yes, sure.
Yeah, you were introducing it and you were saying about the benefits. Can you just give a quick high level, expose about what the benefits are that you've seen? I mean, I think that's a big point you
Yes,
made.
the huge benefits. We will talk about it, but I think it increases students' logical thinking skills and their arithmetics. It's a good practice for arithmetic skills and their problem-solving skills. So I think doing these, and I think it also is very calming and increases perseverance and all that. So we will go through all of that in a minute. So what we are going to have a look, and we will do the practical aspects of it, and then you will be able to see, what the benefits are, and we can discuss it together as well.
Can we just pop onto present mode, Marla?
Okay.
Just down the bottom.
Yeah.
Thanks.
Is that okay? Yeah. Right. So I grew up in India and I'm passionate about maths. I've been in New Zealand teaching for 20 plus years and a recipient of all these scholarships. So I've had huge amount of support. I'm very grateful for that. And I did my PhD thesis on ideas from Indian history. These are my gurus and mentors for my master's papers. It was Professor Bill Barton, and then Mike Thomas and Andy Beck for my PhD, and George Joseph and Professor George Joseph and Srinivasan Rangachari. They are my other, who have mentored me over the years. So an overview is why KenKen, and basically it's got apart from being a puzzle, I think it's got a lot of benefits in terms of the logical thinking, arithmetic thinking, practice of multiplication tables, practice of basic number facts. And there's a lot said about automaticity, which is very beneficial, because if you have enough in your long-term memory, then it frees up the short-term memory for learning, which is the science of learning. So that's really, really good. So we will look at what is KenKen, how to play it, what is my experience, what did I do with my classes, and then we will look at the educational benefits. Okay. So this is what the refreshed curriculum says. By the end of year 6, ākonga should know how to multiply 2 and 3-digit whole numbers, divide whole numbers by 1 or 2 divisors, find factors of numbers up to 100, which wasn't there before, which is new, and recall multiplication and division facts. So, and also, ākonga can explain and justify statements, reflect on other people's thinking and logic. And the numeracy standard, of course, says learners at the benchmark can fluently and flexibly solve problems that require operations on numbers, understanding the relative size of those numbers and making of this sense of the number in context. So this is what the refreshed curriculum says now. About KenKen, this was created by a Japanese school teacher, Tetsuya Miyamako, and it's grid-based. You have from 3 by 3 to 9 by 9, and you have a choice of the number of operations you can use. You can just have one with plus. You can have one with plus and minus, or plus and multiplication. And these are, you can mix and match the operations that you like. So it's really good for students of all, learning levels. The puzzles can vary in difficulty. You have easiest, easy, medium, and hard. And so it's really good as a low floor and high ceiling types of puzzles. The goal is to fill in the whole grid and no repeated number in any row or column. And the heavily outlined areas are called cages. In each cage, the target answer and the operation is given. So let's look at what it looks like. So this is a 3x3 puzzle. So this is heavily outlined. So what this means is the colored yellow doesn't mean anything. I must have clicked on something. So there are 2 cells here in this cage where you have 2 numbers. When you divide, you get the answer to. So what you have here is the answer to, and the operation is division. So here, this is heavily outlined. So here you have 2 numbers. When you subtract them, you get the answer 1. So it goes on like that. And this is one, we have 3 cages here. And I'm sorry, 3 cells. And when you multiply the numbers, you should get the answer 9. So that's what it is. And here there's an example of 5x5 card. So the numbers go from 1 to 5 across and vertical, and they are not repeated. Okay, next one. So this is another example of 6x6 medium. So, and I basically use all the operations for students, but you can choose how you want to do it depending on the number of students you have and their ability level. Okay. And the other thing is, I'll show you the website, and what you can see is that you will see that there's only one correct answer. So in the grid, when you fill it out, it's only one, but it can be approached in multiple ways, and that's why they are so powerful. And solutions are given in the website, and you can search a specific puzzle. Suppose you did one thing yesterday, and a student comes up and says, "Sir, Miss, is this correct?" And you want to quickly give them an answer. You can also find that. So let's have a look at the website. I hope I can access it. Are you able to see it? Are you able to see the KenKen website? No? Okay, I should stop sharing and then screen share, I think, very quickly. I'll stop sharing and then screen share this one. Here we go. Are you able to see it now? So what I generally do, so here is a puzzle. This is the original KenKen website. What I usually do is I create one that I want to show the students. For example, it could be 4x4, and I can choose all the operations, and I can choose easiest or easy, and then I can go play, and then it comes up like that. And I project it on the data screen, and I do it with the students. And what I've done in the past is term 1, year 9s and 10s, I do this puzzle. Year 9 and 10, say start with 4x4 easiest, do a couple of them, then do 6x6 easiest, do a couple of them, and then they get the idea, and then they start trying it out themselves. Now, before I go back to my screen, see, you can enter your puzzle number. See, this is the puzzle number, 151765, and you can enter it, and you can find it anytime you want, and you can check the solution here as well for the students. So that is what I generally do. That's the process. Now I'm going to stop sharing this and go back to the PowerPoint. Right. And there is another one called Crazy Dad, and it's got lots of PDF files. And it's easier to use if you are going to use, write on PDFs. But what I find is it's really beneficial. There's a lot of discussion if they do paper and pencil. And that's what I want to model today. The other thing with Crazy Dad is instead of using the division sign, they use a slant line. So I prefer to use the original KenKen puzzle website. Okay, next one. Are you able to see this, my PowerPoint now? Yeah. Now, why is it that it's not going to the next? Here it is. So what I have done is to introduce it to year 9s in term 1. Then I see some of them who want, and it's accessible by everyone. There is a 3x3 puzzle that's easiest, and it could go right up to 9x9 hard. And once I introduce it, there are students who take their own time. It's not time bound. Once I teach it to them, then that's it. They know it until year 13, when they have finished an assignment or when they have a few minutes and it's the last period of the day and you have 20 minutes to teach them, give them something. This is a good one to do it. And some of them take it home, do it with their whānau, and then come back and show it to me. So there are lots of possibilities. So once you teach it to them in term 1 and you spend half an hour one lesson, another half an hour, another lesson, they are good to go. And then they solve it together. They help each other. So what I do is I bring up an 4x4 easiest on screen, explain the process to class, and we do it together. Which I'm going to show you now, then move on to another 4x4 easiest and maybe 4x4 easy, then on to 6x6 easiest, and it's all solved together. But the reason I would like to, what I would like to emphasize is that it's very important to write possibilities and eliminate possibilities as we go along using logical thinking. And that's what we want to inculcate in our students. And once you teach it to them, many students are, Miss, can I do the easiest one? Or can I try a harder one, kind of thing? So they choose their own levels and they can work individually or in groups, and they can take the sheets home. They don't have to finish it in class. I do suggest to them to use pencil and paper, because once they make a mistake, it makes a mess and they can't really see where they have gone wrong. So it's good to use paper and pencil. I know it's printing off, but I think it's really worth it in the long run. And students work at their own pace. More than anything else, effort and perseverance is praised and rewarded. And that's what the research is saying, to inculcate a growth mindset. All right. So now, why is it not going to the next one? Okay, so this is one of the things that was suggested, that you have a print off, but even if you don't have a printout, it's okay. You will be able to follow what I'm doing, and I'm going to model what I do with the students in class. So let's make a start. So I've got it up here. And I just want to, what's the time? I'm just keeping an eye on the time. Yeah. So here we go. This is 4x4 easiest. And I hope you can see. And what I do is I tell the students, you can start anywhere. It's not specific that you have to start in a particular place. So, for example, there is a 6 here and there's a multiplication sign, 2 cells. What are 2 numbers between 1 and 4 that multiply to give the answer 6? That's what they should ask. But you notice that in this cell, there's only the number 4 and there is no operation given. So that means that's given to you as a start. So students can write that. So here is number 4 written. Are you able to see what I've written? Yeah, so this is 4. I'm modeling, I bring it up on the data projector. It is really big and I write with a whiteboard pen, but I wanted to model this. That's why we have this here. So that's 4. Now, then I ask students, then here is another one, a number on its own without the operation, and this is the thick gauge. So this is another one that's already given. So here is another 4. Then I ask the students, in this cell, there are 2 numbers that add to 3. So what would that be? And they will come up with 1 and 2. But we don't know whether the 1 goes here or the 2 goes there. So that possibility is written here. 1, 2, write it really small. 1 and 2 is written there. Then you can go anywhere. Now you have 6 here. The answer is 6 and it's multiplied, and students will come up with, 1 times 6. Then I say to them, but we only have a 4x4 grid. It's not, we don't go up to 6. So they say 2 times 3, and we write the possibility here 2 and 3 because we don't know whether the 2 goes here or the 3 goes there. So the possibility, writing that is an important part of the process. Then someone may jump up and say, Miss, before we can fill out the others, but they may say, hey, Miss, that's 1 and 2 here. That is a 4. There's only 1 number that's left. So what would that be? And they may say, oh, Miss, you should write 3 here. So we write 3 here because although we don't know where the 1 and 2 go, for now, we know there's a 1 and 2 in this column. There's a 4. And what's left between 1 and 4 is only 3, and you can fill that in. Likewise, we have 2, 3, and 4 in this row. And the only number it can be is 1. I'll come back to that. Suppose somebody had started to do this and they say, oh, what are 2 numbers? When you divide, you get the answer 2. Students will come up and they will say, oh, it's 4 and 2. And 2 and 1. 4 divided by 2 is 2. 2 divided by 1 is 2. So you have the 2 possibilities written here, but you can't have both. But what we do know is that there is a number 2, whatever the possibility, whether it's 4, 2 or 2, 1, you still have a 2 in this column, in this cage. I'll just come back to this in a minute. Then we have here 7 and plus. So 2 numbers added gives you 7, and students will say 3 and 4. And somebody may pipe up and say, oh, 2 and 5, but we don't have numbers up to 5 here. So this is 4 and 3, and we write it here. That's the possibility, but we don't know where the 4 and 3 go. So build it up like that way. For example, here, what are 2 numbers? When you subtract, you get the answer 2. That is 4 minus 2. And I don't put the minus sign here. Just write the possibility 4 and 2, 3 and 1. Those are the 2 possibilities. Then here, you have 4 divided by 2, 2 divided by 1, the possibilities for this cage. Now you can go back and have a look at other things that you can fill in. Right. So we know here that there is 2, 3 somewhere here and 4. So what's left is 1. So 1 has to go here. And then we know that there is 4 and 3 in the 7. That's 4 and 3. And then you have 1. So what's left in this column is 2. So that's 2. So that's 2 and 1. So that means 4 and 2 is not working here. Even otherwise, we can see that there is another logic. We can encourage the students to come up with explanations. Someone will say, Miss, there is already a 4 here. There's already a 4 here. So we cannot have 4 and 2 as the possibility here, and they may cross that off. That might, so there are different explanations. but and different approach it differently in the logic, but the answer will be the same. And the other thing that comes up is in the discussion is that it doesn't have to be in order. So 2 divided by 1 is 2. So that's a 1 and 2. It doesn't have to be 2 first and then 1 next. Right. Then what we also, what is the other thing that we can fill in? So what we have here is 4, 2 and 2, 1. Whatever it is, there is a 2. Whether it's 4, 2 or 2, 1 in this cell, you definitely have a 2. So that means in the last one, in this cage, you have a 1 and 2 in this column, and you have a 2 here. So what goes in here has to be 1. And what goes in here has to be 2. So when I'm explaining it, I tell the students, it seems like it's a very complicated thing, but once you practice 1 or 2 of these and you get the hang of it, they just go and they just do it. So, but for some, the logical thinking is what is really hard, and that's what we want to, model how to approach it, the strategy, and how to eliminate the possibility. So we had the 2 here, that's 1. Now, because we have got the 2 here, in this cage, we cannot have the 4 and 2. We can only have 3 and 1. So now we have 3 and 1 here. I've crossed off the 4 and 2. We have 2 here. So what's left? It has to be 4 here. So we now know between 4 and 3 for the adding to 7, the 4 goes here. And then, of course, the 3 goes here. It's starting to fill up. Again, here there is a 1. So that means in this cage, you cannot have the 2 divided by 1. Because it will be repeated. And that's something students have to explain. If I put the 1 in here, if I have 2 and 1, that means the 1 will be repeated. And so we cannot have that. So explaining and justifying happens along the way. And it can be done collaboratively, or they can check in with their peers anyway. So this is 4 and 2. So you can put in the, because there is a 4 here, you have the 2 here, and then you have the 4. And then it starts to go quite quickly. So 2 and 3, so that means because you have a 2 here in the 6 and the multiplication, you can put in the 3 here because the 2 is already there, and this will be the 2 here. And then, of course, here, this will be 3 and 1 will be 4, and even otherwise, 1 is the thing that is left here. So someone may say 3 plus 1 is 4. That explanation is correct. Or they may say 2 and 4 and 3 is there. We just have, we have to fill in the 1. Then finally, we have 3 and 1. And so we have 3 here. And you have the 1 there. And it's all filled in. Every row and column has the numbers 1 to 4, and it's not repeated. Okay, can I give you a few minutes to try the next one on your own? And I'll bring it up here on the screen. It says 4 by 4 easiest, and it's got a division by 2 in the corner. That's, I'll give you a few minutes for you to have a go at that. And I will just take this off and I'll bring that up and we can go over it together, and it'll be faster this time, of course. So I'll just take this off. So just have a go over the answers. Yeah, I will just go over the answers. There is 3 already here. There is a 2. 2 numbers subtracted gives you 3, 4, and 1. And then I've got 2 numbers added to give 5. 1 and 4 and 2 and 3, and straight away somebody will say we can't have 2 and 3 because there is a 2 sitting here, so cross that off, and that's 1 and 4. And then you have, we don't know where you're going to put the 1 and where you're going to put the 1 and 4, so leave it there for now. And here this is 4 minus 2 is 2, and then you have 3 minus 1, and so we know that somewhere here, there's going to be 4 and 1. There is a 2, and that means this has to be 3. 4 and 2 cannot be the combination here for these two cells. So that's 3, this is 1. And then you have, what else can we fill in? So 4 divided by 2, 2 divided by 1. There is definitely a 2 here, whatever the possibility. Because of the 2 and 3, we know that the 2 cannot be here, it has to be here. And we don't know as yet, because there is a 2 here, and then you have a 3. What else? What are the other possibilities here? So you have 4 and 1 here. It has to be 4 here because of the 1. And then you have the 1. And then you have 4 and 1 here, so it's got to be 4, and then it's got to be 1. You have 1, 2, 3, so it's got to be 4, and that's got to be 1. By this time, when you're doing it in the class, there'll be kids jumping up and down and wanting to come and write on the board and miss, and students are screaming out the answers, and there's a lot of excitement in the class, which is what we want to happen. So this is 2, so that is 3. And then you go 2, and then you have a 3 here, and then you have a 2, because that's what is left over, and it checks with, this is a double check, it's 2 and 3. So we had 1, 2, and 4. So what had to fill in here was 3, and you had 1, 3, and 4. What we could put in here was the only possibility is 2, and then you double check with what's there, and you know that it's 2 and 3, 1, 2, 3, and you have 4. So 2 and 1 was not the possibility. So you fill that in quite quickly. What I thought is we could jump to 6 by 6. We won't fill in the entire thing. I think you may be familiar with this, and then students are also, they are ready to, I do 2 of this and maybe 1 4 by 4 easy before moving on. I sometimes move on to a 5 by 5 and sometimes a 6 by 6. So are we able to, I'll bring up the 6 by 6. We will just make a start. We won't complete it, and then we can talk about some of the benefits that we see. And if there are any disadvantages in using it, we can see that as well. So this one is 6 by 6 easiest in that list, and it's got the puzzle number 95133 in the corner. 95133. I'll just bring that up. Because it's a bigger grid, the cells become smaller, but once you have the idea, well, because you're going to bring it up on the screen anyway. Okay, so this is a 6 by 6. Are you able to see a bit of this? I hope. We can just make a start. We won't complete it. The thing is, students can start anywhere, and it's good to reiterate with them that this is 1 to 6, 6 by 6 grid, 1 to 6 in every row and column, and digits are not going to be repeated. So, and it's good to do the ones where the numbers are on their own and there is no operation. It's good to start there. And so here there is a 4 on its own, and then 3. And look at ones that are easy, and you can start, you can fill in those. So you have 3 and plus and 2 cells. So that would be 1 and 2, and we write that in the corner. I mean, at the top is a possibility. Then we have, then I asked them, there are 12 and multiplication. What are 2 numbers, because there are 2 cells, that multiply out to 12? And students will come up and say, they say 4 by 4 and 3. And because they have done 4 by 4 for so long, they may say, oh, that's it. Are you sure? Are there any other numbers that multiply to 12? And they'll come up with 6 and 2, and we have got that there. Then 15. And you have 5 and 3, and we put that there. And then 3 plus, and that is 1 and 2. So we put down those possibilities. Again, 6. Students may say 2 and 3 and stop there, but say, hey, this is what are 2 other numbers. And then that's 6 and 1. So you put down the possibility. And what are 2 numbers that add? The additions are the harder ones here. But there are some where you have only one set of answers. So for example, 11, when you add, the only thing it can be is 6 and 5. So we keep going like this, and 5 and subtraction, answer is 5 and it's subtraction, then it's 6 and 1. So 6 minus 1 is a 5. And 30 is 6 5s are 30. Okay, you carry on like this. But there is one thing that I would like to point out here, which is something that students take a little bit of time to get their heads around. As we go along, see, this is the easiest. As the grids become bigger and we do the easiest, easy, medium, and hard, there's a deep logic in there that's really very interesting, which helps students to persevere and think about it. So for example, the only possibility here, there is a 5 and there is a minus sign. So 6 and 1 is the only possibility here. And 6 and 5 is the only possibility. That means in these 2 columns, the 6 is used up. The 6 has got a place here or here. In these 2 columns, the 6 is already taken care of. So where we have written 12, 4, 3, and 6, 2, that 6, 2 possibility can be eliminated. We can't have the 6 and 2 because there is already a 6 somewhere here, 6 somewhere here on opposite sides. It could be 6 and 1 or 1 and 6 or 6 and 5 and 5 and 6. So in this column, 6 is taken care of, so you cross out the other possibility. So those are the kinds of logic, and it gets more and more interesting as we go along, that we discuss with the students. For example, this one thing that you can fill in here, you have 6 and 5, and you have 6, 1 here. So there's 6 in this row. So the only possibility is 5 here and a 6 here. And you have a 6 in this row now, you have a 6 in this row. So where you have times and answer 6, you can cross out the 6, 1. So you build this up as you go along like this, and it gets faster. I tend to do, just to get everybody on board, I try and take 2 lessons where first time I may do 2 4 by 4 and 1 5 by 3 easy. And in the next lesson, 6 by 6, easiest, couple of them, and get them to do 1 more. The reason, is that okay? Shall I stop there? And we can, I would like to hear from you guys, what you think of it. So what I find is that, shall I start to share? We are here now. So we have done 6 by 6, we can do an 8 by 8 even, but so this is the one that we have done now, I think. Sorry, it just kept coming off, but this, yeah, I did have it on my screen actually, sorry. So this is the one that we have done. you notice in one place here there is 15 and there is 3 number possibilities here. That's one of the things I get students to do. The addition signs are harder, and when there's 3 number possibilities, you can have something like 4 and 4. You can have 6 and 6. That's 6 here and 6 here, 12 plus 3, 15. There are different 3 number possibilities that you can have. So rather than they start to figure out, rather than writing down all the possibilities, it's good to do all the multiplication, division, and then start working our way to the harder parts. And some students, when they get to the 8 by 8 and 9 by 9, they start to write those addition possibilities, and there is a deep logic there. And it's sometimes 3, because of this happens, and because of that, something else happens. And then they have to write the answer. So it's a 2-step or 3-step logic. And that's really, really, some of them find it really interesting. On the other hand, there are some students who say, come back after 1, 2, 3 weeks. Hey, miss, can we do KenKen? I want to try the 4 by 4 easy. Then you can give that to them. There are others who say, oh, I want to try the 8 by 8 hard. So all those possibilities are there. And I do it with year 13 as well from the start. So when they have finished, when they have done an assignment, or they are doing an internal and they have completed it, or at the end of an exam, we give it to the students. And on a regular basis, at least once a term, I do it with my junior classes. So, and I find that they are engaged, they discuss it together. There's a sort of competition between students who, who are able and they're sort of racing each other. There are others who become teachers, the peer tutors for other students who have been absent or who have got it, and they explain and justify to each other. And that's really good. That's a really good thing that we want students to be explaining and justifying, like in the numeracy standard. Okay, I was talking. So I would like to open the thing for, discussion, what you see in this.
Hi, it's Brad here. I think this sort of activity could fit in quite nicely to some of the activities we do. We do a number sense activity twice a week, and like the bigger ones would take too much time, but that's a good filler activity. But maybe a 4 by 4 could be done, and I think it develops that number sense as well, and logic. You say it's all wrapped in the same bubble, basically. And thanks for that. It's quite interesting. I mean, I was using Sudoku before, but I think this is much more interesting than just a Sudoku now. Thanks for that.
Sudoku is also very good, but it's got the logic. I mean, the numbers are used. It's nothing to do with numbers. You substitute that with any symbols. So this has got the logical thinking, and as well as the the arithmetic skills involved. And I've introduced it to my family. I have everyone from my mother to the youngest ones. Everyone is into it, and they find it. And it's also, there are some health benefits, I feel, well-being. Once some of the weaker ones start to get, 9 by 9 easiest, I give them even 5 or 6 of those till they get the confidence to move to the next one, and they think, I can actually do this, and they start to become interested. Thank you for that, Brad. Anything else that you would like to share?
I think, Marla, looking at that, if we're working in the secondary space, we're working with older students, and often people say coming in with not very good no basic facts. And I thought, here's a great way to help them learn their basic facts in a way that's not going back to like a year 1 or a year 2 in school approach, because it's always hard
Yeah,
ways to build the skills with the students who haven't yet, you know, developed those number skills for whatever reason. Maybe they're new into the country, you know, or they've just missed out along the way. But you've got to find ways that are cognitively like at their level.
that's right. Absolutely. I totally agree with you. I get what you're saying. What you're saying is it's not babyish kind of practicing,
Yeah.
and it's not like a repetitive thing, which is,
Yeah.
mindlessly doing 3 times 2 is 6, 3 times 2 is okay. There's no harm in doing that because it's good. It's good to have the recall, but it's not babyish. And you get to practice that, and just once or twice a term. My year 13s, year 12s always ask to do this. Best can we do KenKen? We've got a few minutes, and they will be chatting, but they will be doing this as well. And paper and pencil really helps. Yeah, it's you're right about the cognitive thing. Holding the pencil, writing the possibilities. There's something to be said for paper and pencil and the thinking and the cognitive skills that are developed. Thank you for that, Robin. Anything else that you would like to share that you notice? You're right, Brad, it develops number sense really well. And we have a hybrid class in year 13, and we do some differentiation and some of the stat standards, and they don't have some of the basics, and they really struggle. And when they are able to do KenKen, the easiest or easy, it's very powerful for them. Oh, I can actually do it. It gives them that confidence to have a go. So basically, it's a really wonderful enrichment activity. It increases, I think, also critical thinking and problem-solving ability, and the arithmetic and the logic to consider possibilities, then by a process of elimination, arrive at the answers and fill up the grid. Enables practice of multiplication tables and basic facts and numbers, which you all pointed out. Rich opportunities for finding factors and multiples. So for example, you'll have something like 728, and okay, what are the possibilities? And if there is a 3-number cell, it'll be 7, 4, and 1, or it could be 2, 2, and 7. So it's a good way of finding factors and multiples. Opportunities for explaining and justifying increases focus, encourages students to concentrate and remain focused, develops perseverance, encourages learners to persevere till they find the solution. And increases confidence, enables players to become more confident. And it also provides opportunities for working together, teamwork, collaboration and communication, and the ability to discuss and reason and support their answers. Oh, I cannot have another one here because in this row, there's already another, the digit 1. So that kind of explaining has to happen. And opportunities for whānau involvement. Students can take the puzzles home, play with their family. And these are 2 papers that I found that is really good. Rita Taunton and Venebush, that's the mathematics teacher from NCTM, and also Klein, KenKen, and the problem-solving classroom. That's an elaborate paper, and they talk about orthogonality and everything, so it goes at a very high level. The possibilities for logic, and there's a very deep logic there as you go up in the number of grids that we can do. So last thing, thank you all so much. I really appreciate it. Thank AMA Online for giving me the opportunity and to share. I've been wanting to share this for such a long time. I've been doing this with my classes for about 10, 12 years, and especially with paper and pen.